Okay, this is going to be part 2 of fraction operations. Part 1 was adding and subtracting, where you had to have a common denominator, and line 1 is highlighted because without a common denominator, you cannot legally add or subtract fractions. So in this video, we're going to talk about multiplying and dividing. And whenever you have a fraction where you're multiplying and dividing, you should feel kind of happy because you just don't have the work that you have when you have to find a common denominator and then make equivalent fractions. Sometimes in subtraction, your top number isn't high enough, so you have to borrow, you have to go through all that process. But when you multiply and divide, in the end, all you're doing is multiplying the two top numerators together, and you get that number. And then you put that over multiplication of the two denominators. And that even happens in division after you flip the second fraction. The major rule here for multiplying and dividing is if you have mixed numbers, they must be converted to improper first. If you try to multiply these fractions without doing that, you'll never get the right answer. So make sure that you follow that first instruction. And let me say that with division, as you know, division, we don't actually divide. We make it multiplication by flipping the second fraction. That's called the reciprocal. You never want to flip the fraction if it's a mixed number until it's been converted. So keep those things in mind. And then let's work on some examples from the pack. Okay, first let's look at a few multiplication problems. The first one is 4.5 times 2/3. So as you notice, 4.5 is a mixed number. So the rule is that has to be converted. And we do that by multiplying 2 times 4 and then adding the 1. So 2 times 4 is 8. Plus 1 gives us 9. That's 9 over the denominator 2 times 2/3. And 2/3 is already a proper fraction. We're good. And we're just going to multiply across. 9 times 2 is 18. And 2 times 3 is 6. Now if you remember from class, I talked about in most cases when you do convert mixed numbers to improper, in many cases, you end up with an improper answer, and that is improper because 18 is higher than 6. And I also said, if you remember, if this denominator is a multiple of 18, then you're going to end up with a whole number as the answer. And sure enough, 6 goes into 18 3 whole times, so the answer is 3. But we can always take our fractions, make a fraction house. That's 18 over 6. 6 goes into 18 3 whole times, which is 18. And that is the answer, 3. Okay, number 2 is 3 1/5 times 1 1/4. Now we have two mixed numbers, so we have to convert both of these. Let's do the first one. 3 times 5 is 15, plus 1 is 16, always over the denominator 5. Then 1 times 4 is 4, plus 1 is 5, and that's over the denominator of 4. And then we're going to multiply across. You want to go off to the side and do 16 times 5. 6 times 5 is 30. 5 times 1 is 5, plus 3 is 8. So the top number is going to be 80. And on the bottom, I have 5 times 4, which is 20. Once again, 20 is a multiple of 80, so we're going to end up with a whole number. And sure enough, 20 times 4 is 80. But again, at any time that you have an improper fraction, make a fraction house. 20 goes into 80 4 times, which is 80. And so we have 0. And the answer is 4. Okay, now let's look at number 3, where we have a whole number. And this is something that this is a skill actually that is almost always tested in multiplication and division. because they want to know, do you know how to write a whole number as a fraction? And we do that by putting it over 1. Not 1 on top. If you put 1 on top, I would make this 1/6. That's not 6 wholes. 6 wholes is 6 over 1 times 1 1/9. 1 1/9 is a mixed number, so let's convert that. 9 times 1 is 9, plus 1 is 10, and 10 over the denominator of 9. And then we just multiply across. 6 times 10 is 60. 1 times 9 is 9. And that again is improper. And let's go ahead and make a fraction house. 9 does not go into 6, but it does go into 66 times. 6 times 9 is 54. I have to borrow. So this becomes 10. And I have 6 left over. And we're done because 6 is less than 9. I'm going to write that as 6 over this divisor. But 6/9 is not in lowest terms because we have common factor of 3. So we're going to divide both by 3. 6 divided by 3 is 2, and 9 divided by 3 is 3. So the final answer here is 6 2/3. Okay, now let's try a couple division problems. Remember, division actually becomes multiplication because we can flip the second fraction, which is the reciprocal, called the reciprocal. We don't actually do any division, which is kind of nice. So let's look at the first one, 5/6 divided by 1/2. We don't have mixed numbers here to convert, but what we do have to do is take the second fraction and flip it. Okay, I lost my page there for a minute. Okay, so we have 5/6, and we're going to flip the second fraction. Okay, there's the second fraction. So we have 5/6 times, let's flip that to 2/1. And then you multiply across. 2 times 5 is 10. 6 times 1 is 6. This is improper again. So we have 10/6. We'll make a fraction house. 6 goes into 10 only one time because 2 times 6 would be 12. That's too much. Minus 6. I have to borrow. 10 becomes 10. And I have 4. So I'm going to write 4 over the divisor. And 4/6 is not in lowest terms. They're both even, which means we can divide by 2. 4 divided by 2 is 2, and 6 divided by 2 is 3, and that ends up with my favorite, which was 1 less than the denominator, so we are done. Okay, let's look at number 6, which is 2 1/4 divided by 3. I'm right up here. 2 1/4 divided by 3. And again, this is in your pack. This is called division of fractions in your pack. So we do have a mixed number we have to convert. 2 times 4 is 8, plus 1 is 9/4, divided by, and this is a whole number 3, and we write whole numbers over 1. Now, this is really important because we have to flip the second fraction, but you can't flip the second fraction until you have it in proper form, and right now it is in proper form. So to make this multiplication, I'm going to flip it. 9/4 times 1/3. And then 9 times 1 is 9, and 4 times 3 is 12. 9/12 is not in lowest terms because we do have a common factor of 3 again, so we can divide both by 3, and 9 divided by 3 is 3, and 12 divided by 3 is 4, and once again we have that favorite 1 less than the denominator, so that is absolutely in lowest terms. Okay, same thing applies for number 3, which is 3 wholes divided by 1 2/5. Now it's sort of reversed. The whole number is first. So we have to write 3 over 1 divided by, and then we have to convert this to an improper fraction. 5 times 1 is 5, plus 2 is 7 over 5. And then to make it multiplication, we have to flip the second fraction, which is 3 over 1 times 5 over 7. And then we just simply multiply across. 3 times 5 is 15. 1 times 7 is 7. That again is improper. The top number is higher. So we can make a fraction house. 7 goes into 15 2 times, because 2 times 7 is 14. And we can't get another 7 in there. That would be way too much. So we'll subtract 14 and we have 1 left over. And I'm going to write that as 1 over the divisor. So the answer is 2 1/7. And we're done because there's 1 on top. It's our final answer. Okay, so one more thing about fractions. Number 4 looks really scary because that's a fraction divided by a fraction. But it's not. All you have to do is write it out like we normally write our fractions. 1/2 divided by 1/3. And now it looks pretty normal. All we have to do, they're both proper fractions, or we don't have to convert anything, is flip the second fraction and multiply, which is 1/2 times 3 over 1. Then we multiply across. 3 times 1 is 3. 2 times 1 is 2. That is still improper. And we have 3 over 2. We can make a fraction house. 2 goes into 3 1 time, which leaves me 1 left over. And I'm going to write that as 1 over the divisor. The answer is 1 1/2. And that's in lowest terms because we have 1 on top. And that is done. Okay, before I end this video, I do want to talk about what cross-canceling is for multiplying and dividing. So although cross-canceling is not mandatory, it will get you to your answer faster. And we do teach that in this class. So, but again, it's not mandatory. So if you don't want to listen, you can stop the video here or we can keep on going. I want to do a couple of the examples from that page for multiplying and dividing. The first one was 4.5 times 2 over 3. Again, this part of the video is going to be about how to cross cancel. Again, we have a mixed number here, so we have to convert that. 2 times 4 is 8, plus 1 is 9. It's 9 over 2 times 2 over 3. So what cross-canceling is, if you can find factors in the top and the bottom to cross out, then you can actually reduce them. Basically, that's what you're doing, is you're reducing these fractions. A legal cross-cancellation is when you cross the fraction bar. So you can cross this way or you can cross that way. You cannot cross laterally. That's a no-go. So let me rewrite that again. 9 over 2 times 2 over 3. Now, if this is not familiar to you, what we're really doing here is we're crossing out the factors. If I would take all these and write them out individually, let's get rid of the 2 there, and I would write this as 2 times 1, and then I write this one as 3 times 1, and I'm going to write 9 as 3 times 3. Then I'm going to go back and cross. What can I cross out by, what can I cancel by crossing over the fraction bar? Well, there's a 2, there's a 2. Here's a 1, there's a 1. here's a 3, and here's a 3. And so all I am left with is this 3 and that 1. So multiplying across, I get 3 over 1. And if you go back to your page, you will see that the answer was 3. And 3 over 1 equals 3. I like to write out the factors so that you can see exactly what you're doing. But I will tell you that a lot of times when you're taught this in school, they basically don't go through that process. Let me do it again. 9 over 2 times 2 over 3. So this one's a little bit more simpler because they'll just go, we're going to cross out our 2's, and then they say 3 goes into 9 3 times. That becomes 1. We have 3 left over. So the answer is 3 over 1. That can be a little confusing if you've never done cross-canceling. So that's why I like to write out all the factors. Okay, let's try another example. How about the second one, which was 3 1/5 times 1 1/4. So now I have two mixed numbers and we want to convert these. 3 times 5 is 15 plus 1 is 16 over the denominator of 5 times 1 times 4 is 4 plus 1 is 5 over the denominator of 4. So I have 16 over 5 times 5 over 4. Again, so this one, I can simply cross out the 5's for sure, but I would like to write 16 instead of 16, 4 times 4. And that way, I have a legal cancel here of 1 4 here and 1 4 there. What does that leave me with? Just 1 4 with 1's on the bottom. So it's 4 over 1 or 4. If you remember, that was our answer for that one. Let's try another one. We did 6 times 1 1/9. Remember, we have to write 6 wholes as 6 over 1 times, we'll convert this one. 9 times 1 is 9, plus 1 is 10 over the denominator. So it's 6 over 1 times 10 over 9. Now, if I write these as a product of their factors, it will make more sense. I can write 9 as 3 times 3. I can write 6 as 2 times 3. And I can write 10 as 2 times 5. And then I can start cross-canceling. Well, I can do 1 3 here and 1 3 here. But essentially, there's nothing more that I can do. You can't cross-cancel this way. That's illegal. So, what I'm left with is 2 times 2 times 5. So 2 times 2 is 4. And 4 times 5 is 20 on top. And on the bottom, I'm left with 1 times 1, 3, which is 3. So I'm 20 over 3. That's improper. I just make a fraction house. 3 goes into 20 6 times, because 3 times 6 is 18. I'll borrow, which leaves me 2 left over. So I'm done because that's less than 3. And I'll write it 2 over the divisor. And that is in lowest terms. And if you go back, you'll see that is the answer. But I did it through cross-canceling. And before I end the video, let's do a division problem. You can still cross-cancel in division. Remember, multiplying and division, you can do the cross-cancel. Number 3 was 3 wholes divided by 1 2/5. So I write that as 3 over 1 divided by, this has to be converted. 5 times 1 is 5, plus 2 is 7 over 5. And if I look at this, I have absolutely nothing to cross cancel. Actually, before I can even say that, let me flip my second fraction. 3 over 1 times 5 over 7. There are no common factors. All of these are prime numbers. So all you can do is multiply across 15 over 7. And again, make a fraction house. I have 1 left over, 2 and 1/7. I did want to point that out because you don't always have common factors to cross cancel, so be aware of that. All right, now let's do number 2, which was 3 over 4 divided by 3 over 7. So I'll make that multiplication by flipping my second fraction. 3 over 4 times 7 over 3. So right now I can see right away I could make this easier on myself by just crossing out the 3's or canceling the 3's on top and bottom. As long as you cross that fraction bar, you're good. It doesn't matter which way you want to go. You just cannot go laterally when you cancel out. So when I do that, I end up with simply 7 on top, 4 on the bottom. That is improper. 4 goes into 7 one time because 2 4's would be too much. That would be 8. So I'll subtract 4, and that's 3. So I'll write that 3 over the divisor, and the answer is 1 3/4. We did that in the other problem, but if you remember, we didn't cross cancel. We just multiplied 7 times 3, which was 21, and 4 times 3, which was 12. So it was a higher number to reduce. So cross canceling gets you there a little bit faster. Okay, and we'll do one more. 2 1/4 divided by 3 wholes. So that is actually, that has to be converted, and the 3 has to be written over 1. So 2 times 4 is 8, plus 1 is 9. That's 9 over 4 over the denominator, and it's divided by 3 over 1. To make this multiplication, we'll flip that one, and the problem becomes 9 over 4 times, flipping, 1 over 3. So you can see now I have some common factors with the 9 on top and the 3 on bottom. So if I write this as a product of its factors, it would be 3 times 1 here, and 9 we would write as 3 times 3. And that will give me factors to cross out. I can cancel 1 3 here and 1 3 there. So what does that leave me with? 3 times 1, which is 3, and 4 times 1, which is 4. And I am done because that is 1 less than the denominator. Okay, so that's the end of part 2 of multiplying and dividing. I think that when you see these problems, you should be pretty happy because it just doesn't require the work that's necessary when you add and subtract with those common denominators. You should, if you see them on a test, you should actually be pretty excited about it, because if you just convert your mixed numbers and you know in division you're flipping, then all you're doing is multiplying the 2 numerators across and multiplying the 2 denominators and then reducing, and you're done. Cross canceling is optional. I like it. Some people like it. If you get the hang of it and you can do it well, then I suggest that you do it because you get to your answer a lot faster. Okay, I hope this helps, and I'll see you in class.